part 2 of question 5. Here they're asking us to solve for x between 0 and 360 degrees, this equation, which is 9 cos squared x plus 5 cos x equals 3 sine squared x. Give each solution in degrees to 1 decimal place. Now, because in the first part we solved it in radians, we have to make sure that we switch back to degrees mode in our calculator. To begin this question, I'm going to remind you of an identity, which is a trigonometric identity. So we've got, if we have an angle, if we've got sine squared theta plus cos squared theta, it is identical to 1. Here I can write sine squared theta in terms of cos squared theta. I can say that sine squared theta equals 1 minus cos squared theta. Okay, now because we have all of these in terms, like this one and this one in terms of cos, and we can't really change this to sine, that is why I chose to write sine squared x in terms of cos squared x. Okay, here I should have written x, but you get my point. So I'm just gonna substitute this part into the equation so that we've got an equation just in terms of cos theta. Okay, so we have 9 cos squared x plus 5 cos x equals 3 times, don't forget the 3 here, 3 times 1 minus cos squared x. Alright, now multiply, open this bracket, so we've got 3 minus 3 cos squared x, and then I'm just going to write that step, I won't skip it. I shouldn't skip this step because it might, end up, I might end up making some silly mistakes, so it's better to write all the steps. 3 minus 3 cos squared x. Now what I can do is, I've got 9 cos squared x here, and I've got a negative 3 cos squared x here. I can add 3 cos squared x on both sides of the equation, so I will have 9 cos squared x plus 3 cos squared x, which would be 12 cos squared x, and then I've got 5 cos x as it is, and I subtract 3 from both sides, so I've got minus 3 equals 0. Alright, now this is a quadratic equation, and as I've mentioned before in my previous videos as well, that I use a method to solve quadratic equations. That method has never failed me, so I will use that method here again. This term, this number that I have here, 12, times this number that I have here, 3. Now, I should look at the sign here because it's negative. I should know that the difference of these two terms must give me 5. And if it were plus here, I would know that the sum of both of these numbers should give me this number right here. So because I've got minus, I should see that 12 minus 3 does not give me 5. I'm gonna write the factors of this. So I've got 4 times 3 times 3. Yes, if I did 4 times 9, because 3 times 3 is 9, I would get 5. So 9 minus 4 gives me 5. So I would say, I would take 9 as positive and 4 as negative. So I would write 12 cos squared x plus 9 cos x minus 4 cos x minus 3 equals 0. You can see that 9 cos x minus 4 cos x gives me 5 cos x. Next, I'm just going to factorize these. So I've got, what's common here? I've got 3, and then another common factor is cosine x. And I'm left with 3 times, so I've got 4 here, cos x here, plus 3 here, right? Here I've got negative 1 as a common factor, and 4 cos x plus 3 is what I'm left with, equals 0. Okay. Now, if I take these as a common factor, I could write them as 4 cos x plus 3, and then I've got 3 cos x minus 1 equals 0. To solve this, we're going to use this same method that we used for the first part. I don't think we have enough space for this. Okay, I'm just going to write this up here. If I take this as equal to 0, if I say 4 cos x plus 3 equals 0, I'm going to write that down here. So 4 cos x plus 3 equals 0, and I've got 3 cos x minus 1 equals 0. This gives me two solutions to cos x. So I've got cosine of x equals negative 3 over 4, and I've got another solution which is cosine of x equals 1/3. Here, because we subtracted 3 from both sides and then we divided both sides by 4, so we got negative 3/4. Here we added 1 to both sides, so we got 3 cos x equals 1, and then we divided by 3 on both sides, so we got 1/3. Cos x equals 1/3. For the first one, as you can see that cos x equals negative 3/4, it's negative something. We have to refer back to our graph here, and then we know from ASTC that cosine of x is negative in the second and in the third quadrant. To find x, I would simply take the inverse cos of negative 3/4. Make sure that your calculator is in degrees mode here. So I'm just going to say the inverse cos of negative 3/4, and that gives me 138.59 degrees. That is this right here. And look at the range. It's between 0 and 360, so we're good if we take both of these, okay? Because both of these lines do lie between 360 degrees. This angle right here is 138.59 and so on. To find this angle, or this angle, because this and this, let me do this in red, this one and this one are both equal. One method of doing that is saying 180 degrees minus 138.59, or we could simply take the inverse cos of 3/4. Just skip the negative sign and you'd get this angle. And if I did that, I would have, let me have a look. The inverse cos of 3/4. It is 41.409, okay? So I'm just going to write 41.40 and so on. And then the same here, 41.409 and so on. The second solution that we have, the first one was this, that I've written down here. The second solution is this right here. So it would be 180 degrees plus 41.40 and so on. So whatever I had here in my calculator, I'm just going to say plus 180, and that would give me 221.409 and so on. In order to write this to one decimal place, I'm just going to do it in the final answer. First, I'm going to come back to this part, okay? For this one, x is the inverse cos of positive 1/3. Now for positive, as I've mentioned before, I'm just going to draw the graph over here in red. Right here. So cosine is positive in the first and in the fourth quadrants. So I'm just going to draw two lines, one here and the other one here. If I did the inverse cos of 1/3, I'd get $70.528 degrees, which is this angle and this angle. So it's 70.58 and so on. Oops. Sorry about that. Degrees. Okay. Now this is also 70.58 and so on degrees. One of the solutions that we've got, I'm just going to write it here, is 70.58 and so on degrees. Okay. And the other solution, simply what we can do is we'll do 360 minus 70.58, okay? So we have this in, sorry, it's 528. 528, okay? 360 minus answer, and I get 289.47. 289.47. 70.471 degrees. To write the final solution, I'm just going to say x equals, I could write it in order. For example, I could write the smallest and then like from in ascending order, so I'm going to do that. Or you could do the first two and then the other two, it doesn't matter. 70 point to one decimal place would be 5. I'm glad that I saw that this wasn't 8, otherwise I would have written 70.6 and it would be a mistake. So the answer is 70.5 degrees, and then the other one is 138.6 degrees. The third solution is 221.4 degrees. And the fourth solution is 289.5 degrees. Yes. And these are the 4 solutions to our equation. I know that I didn't have enough space, but I hope everything is clear. And if you have any questions, you can comment down below. Thank you for watching.